Hey guys, Matt Gunn here, RCGroups.com. I'd like to thank you for tuning in to another video tutorial. And today I'm going to show you how to set up the antenna tracker on an Eagle eyes.vector flight controller. And we'll be using the right wing Z3 Zephyr Spade that you see here on the table. And we've also got some linear polarized antennas instead of the standard circular polarized antennas that are used all the time. I think linear polarized antennas are making a comeback, and one company that is selling a great set is DragonLink. They do have a linear polarized antenna for the VTX. It's a dipole, and they have a very affordable Yagi antenna for the ground. And the Yagi requires it to be pointed at the aircraft pretty much at all times because it has a very narrow beam width. So this is where an antenna tracker is going to come into play. So let's go ahead and take a look at some of the products we'll be using in this antenna tutorial. First of all, I was talking about the linear polarized antennas from DragonLink. This one right here is a Yagi antenna, and it's on 1.2, and we'll be using a ready-made receiver. And basically this is your standard Yagi directional antenna. It is linear polarized, so you must use a linear polarized antenna on the VTX on the aircraft. And we also have this antenna tracker from ReadyMadeRC. Now this comes with servos. You put it together, you bolt it on a tripod here, and basically you have pan and tilt functionality. And it works very well. And this little mount here I actually designed and 3D printed on my CME CNC Rostock V2 Max 3D printer. So it's a nice little unit to hold the Yagi antenna onto this specific antenna tracker. And over here on the VTX, like I said, we have a linear polarized dipole antenna from DragonLink, and this is pretty much a no-frills unit. It is bendable, so you can mount it however you want. And they have a couple different types of this without the lead on it, or with a longer one or shorter one. So it's a high gain antenna. It's got great distance, and that's kind of why I'm using it on this rig. And I'll show you the final piece of the equation that is required to run the antenna tracker, and that is an Eagle Eyes set up here. Now this has servo outputs that drive the antenna tracker, and it also has 2 inputs and 4 outputs for running a pair of diversity receivers, or your goggles, your monitor, and such. And as you can see on the back here of my case that I built, I have various outputs I have inputs for the receiver and outputs for goggles and power as well. So this is just a homemade case that I put together that houses the Eagle Eyes that is required to run the antenna tracker. Now you have the ability to set up the antenna tracker either through your OSD, through the transmitter switches, or you can do it right here, some of it at least, on in your vector configuration, such as the calibrate tracker function. So what's going to happen here is once everything is powered up, it's going to set up the left and right, which is your pan, and then your up and down, your tilt, and so it can understand the limits and whatnot. So we're going to take this out into the field, and we'll run the calibration wizard, and then we'll move on to setting it up through the menus, and then we'll do a test flight. Alright, we're at the field here, and I'd like to apologize in advance for any wind noise that you hear. The wind is pretty stiff out of the south. So we've got our ReadyMadeRC antenna tracker here with the Yagi antenna from DragonLink RC, and it's hooked up via these servo leads through the ground station to the Eagle Eyes antenna tracker and diversity hub. Now you can see right here where it says pan and tilt. That's where the servo wires go into the side. As long as you have that hooked up correctly and the antenna tracker enabled, then everything's going to work as planned. And we're going to set everything up right now through the transmitter. So I'm going to be switching over to the ReadyMadeRC DVR 1000 feed here. We'll fire everything up and get this thing tracking. I'll show you how it works. So all we need to do at this point is set the left and right pan and then the model's location, so the tracker knows where the model is in the sky. So what we need to do is cycle the switch on our transmitter, and then go down to Eagle Eyes Station settings. And at this point, we will be going to tracking antenna setup. And then since our tracker only tilts to about 90 degrees, we'll be using the 90-degree tracker calc wizard. And so I'll enter that by doing right on my transmitter and then on the aileron. And then it's going to ask me to pan the tracker to counterclockwise 90 degrees. So I do that right now by pushing the elevator up. So that turns the tracker to 90 degrees or negative 90 degrees counterclockwise, and then you cycle the mode switch. Now it's going to say go to the maximum mechanical movement of the antenna tracker. So we'll again push up on the elevator to spin it all the way around to its end point and then back it off just a little bit and then hit mode switch again to save that. Now it's going to ask me to spin 90 degrees clockwise. So we'll set that by doing down on the elevator, and it takes a second for it to start spinning. And then once it spins all the way back around, we'll hit the mode switch again. Right about there. Then mode switch to save, and then again maximum value or maximum mechanical movement clockwise. And the mode switch to save it. Now it's going to ask us to tilt to the horizon line, which we want the tracker to be just about level. And we'll do the same thing with the elevator gimbal. Save it by switching the mode switch. Then all the way to vertical, or in this case we can't pan it full vertical, so I'm going to get as close as I consider to be full vertical. And then when you click it, you're done and your tracker is calibrated. And the last thing to do is to walk the aircraft about 50 to 75 feet out. You can see the tracker is going crazy because it's not finally set. But what we're doing is we're taking the aircraft out about 75 feet or so, and then we're going to cycle the switch that sets the aircraft's position so the tracker knows where the aircraft is and can point to it. You can also set this manually with a compass. So you would point your tracker north, south, east, or west and use a compass to set that. So through the menu here, we're just going to set the aircraft, use the model location as the 0 pan. So we'll go up to it and select it at 275 degrees, and bam, the tracker points right to it. Now it's time to fly and see how well it tracks. Alright, as I launch the model here, I wanted to say that you don't have to reset the model location every time, as long as you set the antenna at the same direction as where you previously saved it. So in my case, I set it at 275. Just make sure if you go to another field that your antenna is centered and facing 275 degrees or whatever you set it at the start of each session, and then you won't have a problem. It'll always face the same position. If you don't know your direction and you need to reset it, you'll have to walk the model out or use a compass to set it manually. So as you can see, it's tracking very well, and I'm very close, making 50, 60, 70 mile an hour passes. So the antenna tracker lags just a little bit, and you can speed up the antenna tracking speed in the settings quite easily. So as you can see, I'll make a pass here and it will lag behind just barely, but it doesn't matter. Even that close up, we have perfect signal. There is literally no static at all. So once you get far out, it doesn't really matter, but up close and personal like this, there we go, coming in for a landing, and it tracked it. It's slightly off center, and that's mainly due to the servos not being able to center very well. So there you have it. There's our antenna tracker tutorial. Thanks for tuning in.